Hello everyone, this project is a Confluence-powered internal RAG chatbot. The idea was to build an internal assistant that can read companies' document from Confluence, retrieve relevant information for user questions, generate grounded answers, and also maintain persistent multi-session memory. So this is not just a simple chatbot. It is a full stack application with document retrieval, answer generation, session persistence, and a web interface. So let's talk about the problem statement. In many companies, important technical knowledge already exists in Confluence. That can include environment setup instructions, onboarding notes, process documentation, decision logs, and project specific implementation details. The problem is not always that document is missing. The bigger problem is that it is difficult to find and consume quickly. A user usually has a question like, how do I set up Python for this environment? But Confluence Search expects them to already know where to look. So the problem I wanted to solve was, how can we let user ask natural language questions and get reliable answers directly from internal documents? So what was the proposed solution? My solution was to build a RAG-based chatbot around Confluence. The system fetches document from Confluence through the API, cleans the content, split it into chunks, then generate embeddings and store those embeddings in Astra DB. When a user asks a question, the system retrieves the most relevant chunks, send them to the language model, and generate an answer based on those retrieved documents. At the same time, the question is stored in PostgreSQL using Neon, so the user can generate separate sessions, reopen old sessions, and continue later. So what the application does? From the user's point of view, the application is simple. They only open web interface, either create a new chat session or select an existing one and ask a question. The chatbot answers usually internal Confluence knowledge, and it also shows the source page used for the answer. This makes the system both useful and trustworthy because the user can verify where the answer came from. In addition, conversations are persistent, so users can leave, come back later, and reopen the same session, and continue where they left off. So here is a quick glance to the user interface. So let's talk about the system architecture. The system is built in layers. Confluence is the source of truth for documentation. The backend fetches page content, cleans it, and chunks it for the retrieval, as I said earlier. The vectorized DB or the document chunks are stored in the Astra DB. At query time, Astra DB retrieves relevant chunks and Groq is used to generate the final answer. For persistent conversation memory, I used Neon hosted PostgreSQL. The backend is built with Fast API and frontend is built with Next.js. Now let's talk about one important design decision was separating knowledge retrieval from chat memory. The Confluence documents are shared organizational knowledge, so they are stored as embeddings in Astra DB. But chat history is personal, so it is personal to a session, so that is stored separately in PostgreSQL. This separation lets the assistant handle two different kinds of question correctly. If the user asks a knowledge question, the system retrieves from Confluence. If the user asks something like, what did I ask earlier? The system answers from the chat or the session history instead of document retrieval. So the question is, why choose only these tools? So I selected tools based on practicality and not just popularity. Fast API gave me a clean and modular backend. Next.js helped me build a proper user-facing application instead of only an API demo. LangChain was used where it adds real value, mainly in text splitting, vector store, retrieval, and etc. Astra DB provided cloud-hosted vector storage, which is better for a deployable project than a local-only index like FSSI. Then Groq was used for LLM interface inference. Neon was used for persistent session memory, and finally, Docker made the application portable and deployment ready. Now I will be showing the application in action and demonstrate the complete workflow from asking a question to retrieval, documentation, generating an answer, and continuing a saved session. So let me get out of this presentation and let's open our chatbot. So before we go through this chatbot, let me just quickly show you the database, how it is running. So this is Neon. As I already said, all the chat history or the session history are stored here. So these are the chat messages and these are the chat sessions that are being created on the fly. Now this is Astra DB, which is used for getting the chunks for all the document from the API. I will also show you my, yeah. So this is Atlassian's Confluence pages. So I've made few pages, only 4 to 5 pages right now. And all of these contain some relevant information, which are also generated with ChatGPT only. So let's get into this demo. Let's go. Yeah. So before I start the demo, I can also show you the existing chats that I already had. So if I open the existing chat, so you can see we are asking questions like how does Salesforce improve operational efficiency in this investment banking setup? So it answers something, and we are asking multiple questions to it, and these questions are dependent questions. Like if you see the above question, what are the key modules and features in this implementation? So it found out those things and listed it down for me. And in this, the dependent question was which one of those deals with regular breaches. So it found out from these uh, replies, and from the dependent context it gave us an answer. Now we also checked with asking something which is not in the Confluence. So a RAG shouldn't be answering things which are out of the scope. So we simply asked who is the CEO of Salesforce, and it's correctly said that it doesn't have that information. Okay, so let's go with starting a new chat. So the new chat history is created. As you can say, the date and time is also being inputted. And let's go with the prompts. Okay. So the first prompt I have is, can you explain the main application component in investment banking? Let's see what it gives us. So just to mention in the meantime that currently I'm using a very small model, which is Llama model from the Groq application inference that I'm using. So the answer we got for this question is from multiple documents. Like it found out from the document one, Salesforce implementation guide, which also had something relevant to this question, and platform overview application components document as well. So let's say we are interested in the document 2, and I want all the most of the details or all the content from this. So let's go with the second prompt. Okay. So tell me in detail from the document 2 only, and it says, yeah. So it says only to get the details from the second document. And let's see what it replies again. So as you can see, so it is replying based on the retrieved Confluence context specifically from document 2. Here is the information about the platform overview. Investment banking engineering platform supports pre-trade analysis. So we can even see and if it is correct or not. Let's go here. And I guess this is the first line only, right? So what next thing we can do? We got the text as it is and we got it in a very natural way from asking questions. But we can also get things that are not there in the document. Like let's go to this particular conference. So if you scroll down, you won't see any tables here, right? Now, if we ask, since the models are smart enough to make tables for us, so it makes the understanding of the things very easier, right? So let's try it out. Since the model is not that powerful, so it won't give you a perfect table, but let's give it a try, right? So as we can see, it found out these details, the things that we mentioned, that we asked, now convert the same platform component into a table with these columns. We specified the columns like component name, main purpose, programming language, owning team, latency target, and deployment style. So we got things in a tabular way. Of course, this is a llama model which is of 8 billion parameter or something. So it is very small model compared to the chat GPT or the uh, Groq or any other big models that we use in daily lives. Okay, so let's see if it is there in the document itself. So we can see if we read this paragraph, the trade capture service is the first core backend component after the portal. It is implemented in Python 3.1, use 3.10, I'm sorry, using Fast API and is owned by Trade Workflow Engineering team. So if you can see, so trade capture service, we can see Python 3.10 is here, trade workflow engineer team is here. So it is correctly making a table. So the point was we are getting a table which wasn't in the document itself. So this signifies that we can even use the model's capabilities to make the understanding of these conference pages easier, much easier. So this was it for the quick demo of my application. It is hosted at this Vercel link. You can go ahead and try it yourself. Yeah, thank you. So have a nice day.